Welcome to my channel. I am Baran, a solo game developer, building a multiplayer horror game from scratch. On this channel, I share full process, both the smooth parts and chaotic ones. Whether it's an AI perception systems, multiplayer networking, or spooky atmosphere design, you are in the right place. If you enjoy game development with a touch of madness. In this series, I will show you how I gave NPCs the ability to see, hear, and eventually act. Each episode dives into different model with hands-on explanations, design breakdowns, and all the little surprises along the way. So let's dive in and take a look what we built together. Writing a system is easy, but making it work in another scene, that's when the boss fight begins. To help NPCs perceive their surroundings, we started from the ground up. First, we separated the perception system from the rest of the game and made it independent. Each NPC is derived from the NPC generic scene, but now it has its own perceptor scene. Thanks to this setup, both visual and auditory perception are now modular. Initially, everything was jammed inside the zombie generic scene. This caused major issues for reusability and maintainability. Visual range, audio detection, movement logic, they were all bundled together. Over time, this made the system bloated and unscalable. So we pulled out perception into dedicated scene and created the cleaner, more flexible architecture. The result? This first step gave us sustainable structure on the development side and introduced meaningful variation in the player experience. Perception is no longer one size fits all. Each NPC can respond differently, and that adds richness to interactions. ShapeCast vision. With ShapeCast, NPCs act like Legolas from the Lord of the Rings. We started off with RayCast to implement vision, but the field was so narrow that NPCs could only detect objects directly on a lane. It was a perfect setup for a tunnel vision. To solve this, we switched to ShapeCast. The vision area became rectangular volume instead of a single lane. This allowed NPCs to detect not just what's in front of them, but also the general direction of the movement. In short, they started seeing properly. They still can't shout, "Orcs are coming!" from the miles away like Legolas, but at least they no longer ignore someone walking straight at them. The result? Giving vision a volume opened up near-stealth tactics and escape routes for players. Now it's not just about staying out of the sight, it's about staying out of the line of sight. Auditory perception. Believe in Area 3D. Once vision was sorted, we moved to the hearing. We used an Area 3D based detection system. When a player steps, they create a temporary scenes named sound pulse in the scene. If this pulse enters an NPC's hearing area, it triggers perception. The biggest hurdle here was getting the Area 3D layers and masks configured correctly. If they were off, sound wouldn't register physically, and from the NPC's perspective, nothing had happened. This visible failure made debugging a nightmare. We also allowed every NPC to have custom hearing radius. Some NPCs are hypersensitive and hear even soft footsteps, others only react to louder sounds. The result? Adding auditory detection made players aware of the power of the silence. It's no longer enough to say stay out of the sight. Sound can betray you too. Multiplayer sync. The NPCs on the client side were both broadcasting and listening. Eventually the traffic collapsed and packets needed therapy. Building perception was one thing. Making it work in a multiplayer setup was a whole different beast. Everything seemed fine until we tested with more than 4 players and 5 NPCs. The problem? Client-side NPCs were supposed to only receive data, but due to misconfiguration, they were also sending their own position back to themselves via RPC. This created a feedback loop and unnecessary traffic. Results? Player getting disconnected and the network choking. This issue was rooted in the misuse of is multiplayer authority functionality. Everyone was talking, no one was listening. It took a long debug session to get to root. We also dropped controlless player setup. Previously used to render player visuals without control logic. It was functional but fragile. Replacing it with a unified structure made the scene cleaner, syncing much more straightforward. In multiplayer systems, perception isn't just about sending the right data, it's about knowing who should be sending at all. By quieting down unnecessarily chatter, the system becomes much easier to understand and manage. SoundFactory. We built an orchestra with a Singleton, and out came a footstep symphony on single boot whip. We wanted more control and structure in how footsteps sounds were managed, so we created SoundFactory, a Singleton that acts as a central sound hub. Now, when players or NPCs make a sound, they don't spawn note manually. SoundFactory handles it. This factory creates soundball scene prefabs on demand, places them into the game scene, and triggers auditory perception. Not only does it reduce clutter, but it also makes debugging much easier. For now, each player triggers a step sounds locally based on movement. This isn't synchronizing over the network, but integration with multiplayer is planned. The result? SoundFactory turns sound production into something structured and predictable. No more chaotic note spawns, just clean, consistent sonic feedback. Perception architecture. The first version was chaotic but alive. Now it's organized, and even the architect from the Matrix will be impressed. In the early days, perception lived inside NPC generic. It worked, but it wasn't scalable. With the new structure, perception became its own scene, and visual and hearing logics was split across dedicated modules. The perception class doesn't make decisions. It gathers environmental data. It uses ShapeCast for the sight and Area 3D for hearing, working with tandem with perceptor scene. Each NPCs can have different view and hearing distances. Other systems like Now2Lock and NPC communicator base now interact with perception independently but cleanly, keeping the architecture modular and tailored. This new architecture makes NPCs more than cookie-cutter clones. Each one interprets the world differently with unique sensitivities. Now they are not just reacting, they are experiencing their own version of reality. Between eyes, ears and code. We have perceived, we have sorted, we have solved. Next up, giving NPCs a mind of their own. This series was all about laying the foundation for a robust perception system. We opened the eyes, tuned the ears, stabilized the network, and made it all modular. Every part from Singletons to ShapeCast played its role. But this is the just beginning. In the next chapter, NPCs won't just perceive their environment, they will start to respond. They will make decisions, show reactions, and behave intelligently. In that episode, I will share how we are designing and prototyping this new behavior system. If you enjoyed this series, consider subscribing to the channel so you don't miss what's next. See you soon.